Alright, here we are with section 3.4. This is the last section of this module until we have a quiz. So in this section we're talking about graphing functions. We've already talked about that a little bit, but we're just digging a little deeper. So how do you graph functions? First thing we're going to do is say, given a certain domain, so this would be our domain, given that certain domain, what do we do with our equation to allow us to graph it? Okay, so we're given an equation here. Y is equal to 2x minus 3. Alright, cool. The y is by itself. We always want the y by itself. And I'm just going to rewrite it in function notation because a lot of times we see this thing called f of x, which gets a little bit confusing, but it's just saying, it's just another way of saying y. What's the output when x is the input? Alright, and here's our domain. So anytime we're going to graph, we're going to make an xy chart. Alright, so here's my xy chart. Notice f of x is just another way of saying the output. What's my y? What's my output? So our domain is dealing with our x values. So I'm going to list down my x's, -2, 0, 2, 4. This is on a certain domain, so these are the only 4 numbers that are allowed in my domain. And now let's see, these are my inputs, my domain. Now let's see what my range is, what my outputs are. Alright, so to get f of -2, we're going to look and see my x is going to get plugged in to my x in my equation. So we would get f of -2, that's what my x value is, that's what I'm plugging in, is equal to 2 times -2 minus 3. Right? And when we simplify that, 2 times -2 is -4 minus 3, which is -7. -7. Alright. For my next x, I have an x of 0. So we're going to use that exact same equation. That's our equation all the full time. And we're going to plug that 0 in for our x's. So we get f of 0 is equal to 2 times 0 minus 3. 2 times 0 is 0 minus 3, which is just -3. So f of 0 is equal to -3. Alright, our next x, our next input is 2. So same thing, use that equation to plug them in. We get f of 2 is equal to 2 times 2 minus 3, which is 4 minus 3, which is 1. Alright. Last y value of 4, if you plug that in, f of 4 is equal to 2 times 4, which is 8. 8 minus 3, which is 5. So all I'm going to write here, instead of writing out the word, is f of 4 is equal to 5. Alright, awesome. So now what we have here is we have our 4 coordinate points. And these are the only 4 coordinate points that are going to go on our graph because we were given a specific domain. That was our domain. So when we look at our x, y values, we're going to plot all of those. So our first x, y value is -2, -7. So we're going to go -2 on the x, -7 on the y, and we end up right there. Our next coordinate point is 0, -3. So we go 0 on the x, -3 on the y, and we get a point right there. Right? 2, 1, 2, 1, and 4, 5. 4, 5. Alright, so your intuition might be to connect these. That's what we've always been told, connect them with a line and put arrows at the end. But this was a given domain. We only were allowed to plug these 4 values in, so these are the only outputs we could get, so we cannot put a line there. This is on a specific domain. Let's look at one more example on a given domain. We'll put a different domain, which will change our x values. We're going to have a totally different equation, which will give us different y values, different outputs. And we're going to have something different on our graph. Alright, so the equation that we're going to work with next, we're still going to be working on a limited domain, on a given domain, and we're going to be working with the equation 4x plus y equals 10. So that's the equation. It looks a little bit different. It doesn't look like it's in our y equals mx plus b form, so we're going to rearrange it so that y is by itself. So it's in y equals mx plus b. Alright, so if we want y to be by itself, we want the 4x to move. So we're going to subtract 4x from both sides. 4x minus 4x is 0. So we have y is equal to 10 minus 4x. Or if we use our function notation, we're going to get f of x is equal to 10 minus 4x. Alright, and the domain that would have been given in the problem would have said, okay, we're going to limit our domain to 0, 1, 2, and 3. Awesome. So with this given domain is always our x values, our inputs. So we're going to list them right down in our xy chart as our inputs. And to find our outputs, we use the equation that we have. We take our x's and plug them in. So we're going to get f of 0 is equal to 10 minus 4 times 0. 4 times 0 is 0. 10 minus 0 is 10. Alright, when we plug 1 in, f of 1 is equal to 10 minus 4 times 1, which is equal to 10 minus 4, which is equal to 6. And continuing on, f of 2 is going to equal 2, and f of 3 is going to equal negative 2. If you don't believe me, just plug them in and check the work. Alright, let's graph these. So we now have xy, 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 xy. We've got 4 xy points. We've got 0, 10, cool, 1, 6, 2, 2, and 3, negative 2. Again, you cannot connect these. You cannot connect these because it's a limited domain. It's not the whole domain. So we don't connect them. We just leave them just like those 4 points there. Those are the only 4 inputs that we're allowed. These are the only 4 outputs we can get. Those are the only 4 points that we can have. Awesome. So I'm going to give you guys one to do on your own on a limited domain. If you still need these, remember you can always just rewind, finish whatever notes you were working on. Okay. So remember, when you're going to graph this equation, you're going to be doing it on the left-hand side, and make sure you're using function notation, meaning you're using that f of x. Complete that problem on the left-hand side with a domain of negative 1, 0, 1, 2. Alright, pause the video, complete that on the left-hand side. Alright, if you're back with me, I'm assuming you've already completed this. So I'm going to go ahead and erase this. The next ones we're going to be doing is going to be graphing functions with a domain of all real numbers. So meaning we're not restricting the domain anymore. So now that's the time we get to draw the lines and have the arrows at the end. With domain of all real numbers. That symbol just represents real numbers. Alright, the first one we're going to do is going to be y is equal to 4x. So we always want to check to make sure in our equation, is our y by itself? It is, so we're good. But we're going to write it in function notation, just to make sure we get comfortable with that, function notation. And we're going to think about what kind of x's do we want to look at if we're looking at a domain of all real numbers. So truth is, you can choose any x's you want. You can choose 100 different x's, you can choose 5 different x's. You need to choose enough x's to know what your line looks like. So if you could tell me that this was linear, you only need to choose 2 points for linear. But it gets a little different after that. So let's just go ahead. Typically I do negative 2, negative 1, 0, 1, and 2. Those are the standard ones that I like to stick to. Doesn't mean you have to. You could choose any x's you want to plug them in, but these are the ones I like. So if we think about f of negative 2, take the equation that we have and we plug in that negative 2, and we're going to get negative 8. F of negative 1, we plug in that -1, and we get -4. Okay, f of 0, we're going to get 0, f of 1, we're going to get 4, and f of 2, we're going to get 8. If you don't believe me there, you can plug those values in and check. And let's go ahead and graph them, make sure we've got a good idea of exactly what our graph's going to look like. We have 1, 2, 3, 4, 5 different coordinate points. First one at -2, -8. Next one at -1, -4. 0, 0. 1, 4. And 2, 8. Oops. Cool. So on this one, do we connect the dots? Do we make it a line? Yes, because it's a domain of all real numbers. It's not saying that these are the only inputs. It's saying that we could have any inputs. So any inputs at all is going to give us a lot of different options for outputs. So we connect the line as straight as we possibly can, and we put some arrows at the end. Awesome, one more I want to do because it's not going to be linear in this case, and we're going to see how that's going to affect our outputs. So let's look at a different one that's not linear. You'll have one to do on your own. Notice how my scale on my graph is only going by ones. You're more than welcome to graph it any way you'd like. If you want your scale to go by twos, that's totally fine. If you want it to go by threes, that's fine too. It's really however you want your scale to go by. So next one we're going to graph is y is equal to x squared. You might notice that there's a little square up there. That looks a little different than the ones we've done before. So it's going to look a little different when we graph it. But the y is by itself, so we like that. Then we're just going to change the y to f of x because that's our function notation. And we're going to get comfortable with that notation. So f of x is equal to x squared. Okay, it doesn't tell us a domain, so we don't have specific x values to plug in. So we're just going to pick some. Ones I always pick, -2, -1, 0, 1, 2. I like sticking with those. You're more than welcome to choose other ones if you like. Okay, for f of x, we're going to take those and plug them into the equation just like we've done in all the previous examples. So f of -2 is equal to -2 squared. If you don't know what that squared is, let's take a little bit of a closer look. -2 squared is saying -2 times -2. Okay? A negative times a negative is a positive. 2 times 2 is a 4. So we get a positive 4 for that one. Right? For f of -1, we're taking that -1 and plugging it into the equation here. We get -1 squared. -1 times -1 is going to be a 1. Alright, 0, when we take it and plug it in, we get f of 0 is equal to 0 squared, which is just 0. F of 1 is going to be 1. F of 2 is going to be 4. If you don't believe me, you can plug it in and check my numbers. So when we go to graph that, let's graph these 5 coordinate points we have. We got -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. So first thing you might notice is we definitely can't connect this with the straight line. So you're thinking, how in the world do we connect this? Okay, well, if I tried to just connect it with maybe 2 straight lines, that would be one of my straight lines. That would be the other one. So that didn't work because I have to include all of my points on there. So those 2 straight lines didn't work. So you just kind of have to see what the shape of the points are taking. And this happens to look sort of like a U. And we call this graph a parabola in mathematics. So that ended up looking like a parabola. If you weren't sure about the shape, you would have to keep picking x values until you were sure about the shape. So you could pick as many x values as you possibly needed to get that shape. Alright, I'm erasing all of this now, and I'm going to have you guys do 2 on your own. So I'm going to erase this whole thing. If you still need it, just go ahead and pause it. Alright, we are doing 2 on your own now from page 139, number 4, and number 5. You're going to complete those on the left-hand side just like we did. So you guys are graphing these on a domain of all real numbers, making sure that you make an XY chart. Making sure you make an XY chart. I will show one example for number 4 because I don't want to see mistakes there. It says f of x is equal to negative x squared. This negative gets applied last. So if I plug in an f of 4, it's going to be negative 4 squared. Okay, 4 squared is the same as 4 times 4. So it would be negative 16, which is just a negative 16. So make sure you do that right on number 4. Alright, so pause the video and complete those on the left-hand side. Alright, if you're back with me, I'm assuming you completed those on the left-hand side. So I want to do one last thing just with function notation because there are so many errors with function notation. Function notation. Okay, so function notation is f of x is equal to, let's say, 3x minus 4. Let's look at the various components of this. So we have your x, which is your input. Okay, what's your x value going to be? What's your input? Well, your input also is going to go right there. Okay. The whole right-hand side here, that whole right-hand side is your equation that represents the situation. So it's your equation. And your f of x, this whole f of x represents your output given the input of x. So I want to show one last example of this to make sure we're good at reading a graph and seeing how we can use function notation there. So I'm going to give you guys a graph with a couple points. And I'm just going out by ones here in the graph. Okay, so the couple points I'm going to give are going to be 1, 3, 3, 1, negative 1, negative 1, 0, 0, negative 4, 1, and negative 5, negative 2. Okay, I'm going to go ahead and write in these points because my graph is a little bit hard to read. So I'm going to write them in just so I make sure that you guys have the information you need to answer the questions I'm going to ask in just a second. So you have 0, 0, 3, 1, 1, 3, negative 1, negative 1, negative 4, 1, negative 5, negative 2. Okay, so you have all the coordinate points there for this graph. I'm going to ask you a couple questions. So we're going to talk about what is f of 0, what is f of 1, what is f of 3, and then a couple more. So f of 0, if we look at f of 0, it's saying that our x value is 0. So we're going to look along our graph and think, when is our x value 0? So our x-axis is horizontal. It is 0 right there. That's our x value of 0. Okay? And what point lies on that line? 0, 0. So what is the y value at that point? 0. So this is the x. This is the y. Okay. Alright, next one. F of 1 is saying, alright, at my x-axis of 1, what's my y value? Okay, so when I have an input of 1, my y value is 3. Alright, and last one, f of 3. So for my x of 3, what's my y value? My y value is 1. So f of 3 is 1. So I want you guys to answer based on this exact same graph, 3 other questions. I want you to answer what is, I'm going to erase these actually and I'm going to write them right here. What is f of -1, f of -4, and f of -5? Alright, if you want to answer these just on the right hand side, that's okay with me. But that does conclude our video of 3.4. This is the last section of this module.